Hello everyone, I'm Swati and welcome back to another video. Today we are living in the AI era and we are generating a huge amount of data, images, videos, document, PDF, audio files and much more. But here is a real problem. How do we search through all this data intelligently? For example, imagine you have thousands or millions of images. And if you use the traditional database, you can search by file name, tags, IDs or keywords. What if the file name is not useful? What if the image does not have the right tag? And what if you want to search based on meaning, visual similarity, or context? This is exactly where normal keyword search becomes limited. In this video, we are going to solve this problem by building an AI-powered image search project. We will take the images, convert them into embeddings, store these embeddings into the vector database, and then search for visually similar images. By the end of this video, you will understand what a vector database is, why it is so important for AI applications, and how to use Milvus and Zilliz Cloud to build a real image similarity search demo. If you're already familiar with vector database and embeddings, you can directly switch to the timestamp where I have already mentioned about Zilliz and Milvus Cloud and start building the projects. But if you are new, then let me introduce what exactly the vector database is and I'll explain you everything in detail, and we are going to make a project by using Zilliz Cloud and Milvus. So let's start this. So let's understand this through an example. First, just understand that why traditional databases are not enough. First of all, imagine you have millions of photos on your mobile phone in your gallery, and now you are supposed to upload a picture of a wild dog. You ask basically, show me the similar images. So a normal database cannot naturally understand this image. It can understand only the things like file name, tags, keywords, and IDs. But AI understands the actual meaning and visual pattern inside this image. Let's understand what embedding is. So first, the AI model converts this image into numbers, right? And these numbers are called as vectors, and that is the process of embedding. So for example, if we are having this picture of dog, so basically AI understands the numbers. So this image will get converted this sort of numbers, and this number represents mathematically. Why do we need a vector database? So now imagine doing this for millions of photos, videos, documents, PDFs, audio files, right? So this is really a very hectic process, so strong, and searching these vectors efficiently is very difficult for normal databases. So that's how the vector database solves this problem. So that's why vector databases are very important for AI applications. So let's understand what vector database is. Vector database is a special type of database designed for AI applications. Instead of storing only text or numbers, it stores embeddings, numerical representations created by AI models. These embeddings help AI systems to understand similarity, meaning, and context. Let me explain you with a real example. Suppose you search on Netflix movies similar to Interstellar. Netflix is not searching the exact keyword. It is finding movies with similar patterns, themes, emotions, and embeddings. That similarity search is powered by using vector database. Now that we have understand why vector databases are important, let me take a quick look at one of the most popular vector database technologies in AI space, that is Milvus. Milvus is one of the most starred vector database on GitHub with 44K stars. Now you can look at here 44K stars, which is really amazing, and a massive open source community. Milvus is built specifically to store, index, retrieve high-dimensional vector embeddings in milliseconds, which makes it a powerful choice for modern AI applications. Whether you are building an image search, semantic search, recommendation system, RAG applications, or even if you are building multi-model AI projects, Milvus can help you search through massive amounts of unstructured data based on meaning, similarity, not just keywords. So here you can see that on the Milvus GitHub page, you can see the open source project behind the technology. You can visit this page. I have already mentioned the link on the description box for your reference. So here on this page, you can see open source project behind the technology along with a large number of stars and active developer community. So in this video, we are going to use Zilliz Cloud also, the fully functional cloud service built on top of Milvus to power our image similarity project. You know what? Milvus is truly amazing because I myself have tried it multiple times, and here you can see the demos and tutorials also. Lots of tutorials related to RAG, semantic search, hybrid search, quick start, recommendation system is already provided. The ecosystem and integration is really very helpful for you, and the whole documentation behind this Milvus is already provided here. Let's do one thing. Let's just go to the Zilliz Cloud here and see how we can start using it. Here we can see that Zilliz Cloud is positioned at high performance vector database for building AI application. To get started, we can just click on the free button. But prior to that, let me just explore you this page. So Zilliz Cloud is the most powerful and vector database built on Milvus. So here we can see that it is a fully managed vector database and data services, empowering you to unlock the full potential of unstructured data for your AI application. So why Zilliz Cloud is so important? So here we can see that the superior AI powered searches here, smarter query optimizer, optimization suite. So everything is just a one-stop platform for all your AI needs. So here we can see high performance and scale. It is fully managed and tailored compute. And here we can see that it is multi-cloud, flexible deployment, resilience, and enterprise grade security also. So build faster with a comprehensive suite of vector database features. You can explore lots of features here. And here you can just see that there are lots of companies which already worked and which already trusted Zilliz and Milvus. So that's why it is one of the best platforms. So let's just start using Zilliz and Milvus here for making our project. All right, so first let me just explain you what kind of project we are going to build. So basically we are going to build the image search project, in which, let's say, the name of the species is Afghan hound, right? When I'll just search about Afghan hound, I would like to see all these images which is related to Afghan hound in my image search related model, right? So how we are going to implement that? So for that thing, simply we are going to use Google Colab. So this is the whole interface of the Google Colab. And the first step we are going to implement is about installing the libraries. So let me just write the code here for installing the libraries. So simply I am writing here pip install PyMLVS upgrade and pip install tim. Let me just run this code. So this is the step where we are going to import all the libraries, install the libraries, and after installation of the libraries, we are going to download the data set. Because for the image search model, the data set is really mandatory. So let's just implement this all steps one by one. So here we can see that all our requirements are satisfied. The downloading process has been completed. And then the second step that we are going to implement here is we are going to download the data set. So here the data set is of the GitHub Milvus, and we are going to just do this step so that we can download the data set, right? So this process has been completed. We are already having the data set. Then the third step is about feature extractor. So for feature extractor, we are simply going to write a code here. Import torch, which is the library. Along with that, sklearn processing normalized. Along with that, import tim.data. So all these things that I've written here, I've already provided these things on the description box, so you can just check out that. So in the class, we are going to make feature extractor. This feature extractor will definitely help us to extract all the features that is being required in the data set. So we are simply writing this particular code. Along with that, we are creating here some user-defined functions. Input images, so whatever be the path of the images we are going to provide here. The ultimate objective of this particular model is that if we are searching for any of the images, we are going to see all the similar images that is associated with our input image, right? So simply we implement this particular code. And after implementing this code, the second step that we are now going to do is very important step. We are going to connect Zilliz Cloud here so that we can simply, like if we are having the cloud, then definitely our storage and everything will be managed in a very efficient manner. So here we have created our Zilliz free account. So here we can see that connect. Here we are getting the token, right? And next to it, it's a connection guide. So simply I have selected here Python. And here we are going to get the URI. So here from here will get the URI and the token. So what I'm going to simply do is in this particular step of connecting Zilliz Cloud. So here it is the code. Here we have pasted our Zilliz URI and the token. So these two things that we have already seen here on the Zilliz Cloud, that is our URI. So let me just show you here again so that there will not be any confusion. So here is our URI and the token that we have selected. So simply let me show you the token also. In the connect, we are getting the option for token. So simply I'm going to copy the token from here and simply we are going to paste it here. So this is the particular code for connecting the Zilliz Cloud, and this process has been successfully conducted because we are seeing here connected to Zilliz Cloud, right? So after connecting to the Zilliz cloud, the fifth step is going to create collections, because right now we are having the cloud, so we can create the collection of the images. So here we can see that collection name is image embeddings. Here we are having the complete code which will help us in creating the collection. So finally this step is already been done. Like we can see that the collection has been created. Now it's time for moving to the sixth number step, which is like insert image embeddings. So whatever be the images we are having, right now we are dealing with the vector database because Zilliz and Milvus is expert on that. So the ultimate step is inserting the image embeddings here. So we have already used feature extractor. ResNet 34 we are using. Along with that, the complete embedding part has been done. So whatever be the file name, path, and everything related to that particular image will be used here. And here we can see that all embeddings are inserted. After that step, we are going to finally search for the image. So let's say here we are writing the code for searching the image, and that is Afghan hound, right? I would like to search all the images that is related to this particular animal, which is Afghan hound, right? So what I'm going to write here, so simply I have written the query Afghan hound, and that is the JPG image. That is the simple query I'm writing here for searching the image, right? So this process has been done, and finally we have searched for the image. Now it's a peak time to see what kind of response we are getting. So it's a time for the showing of the result. So simply this is the code that we have written for showing the result. As soon as I'll implement this particular code, I am getting this response. My query image is for Afghan hound, and see all the images that is related to Afghan hound we are getting here. So that is the beauty of this particular model that we have already built here, that is related to image search. As per your search query, all the particular images that is related with your input image is something the similarity concept has been beautifully described here and showed here while we are making this particular project. So I'm hoping that this project will be really helpful for you and you can try this. I've already mentioned the link of Zilliz as well as Zilliz Cloud as well as Milvus on the description box. So this is something which we have built in today's class, and I'm hoping that you will also try on your own to learn more about Zilliz Cloud and Milvus. So that's a complete image search project using Milvus and Zilliz Cloud. In this video, we converted image into embeddings, stored them in vector database, and used similarity search to find visually related images. Most AI demos work well at small scale, but real AI systems need production-ready vector search. That's where Zilliz Cloud takes it further with up to 10x faster search, elastic scaling, and zero DevOps overhead. And the free trial, let me show you the pricing also. This is something which is really amazing that we can try this for free, just that we have used in this project as well. So basically at this free tier, it includes $100 in free credits, 5 GB storage, which is perfect to start your semantic search journey. And all the links are definitely there in the below description box. And I would say that I've tried many things, but this is something that Zilliz Cloud and Milvus are something which is very amazing as per the modern AI application. So this is something which you need to try on your own. And I'm hoping that this video would be helpful for you. So that's all for this particular video. Try Zilliz and Milvus. The links are in the description box. And let me know in the comments how was your experience for using Zilliz and Milvus Cloud. So that's all for this particular video. Looking forward to meet you in another video. Stay curious and keep learning.